And welcome to the last lesson in Unit 5. I know it's been a big lesson or big unit, folks, and we split into two parts, but now we're doing our final review of quadratics for Test 5B. All right. So taking a look at our topics, folks, number one is the number of solutions. Remember, another name for solutions is roots. X-intercepts or zeros, the same as solutions. And you can have three answers here. You could have 0 roots. Okay, how does that look on a graph? Either the vertex has to be above it and it opens up. Okay, or the vertex is below it and it opens down. Okay, recently we've been talking about quadratic formula, and the key to remember here, folks, is if you get a negative under the square root, that's your key here to tell you that there are 0 solutions, okay, or 0 roots, okay, or none. Okay, if you want me to put down none. Okay, what about if we had 1 root or 1 solution? What does that mean, ladies and gentlemen? That means that the vertex either has to be on the x-axis and either open up, or it's on the axis and it opens down. Okay? How do we see that with taking a look with our quadratic formula, folks? That's going to give you a square root of 0. So that means the plus or minus will cancel. So whenever you're doing something, you get the square root of 0. That's going to give you 1 root or 1 answer. And the last one is you could have 2 roots or 2 answers. Okay? And the way that looks is if you have a parabola and opens down with the vertex above. Okay? Or it's below and it opens up. Okay? And when you do that, folks, you're going to have a positive value in here under the square root. So that's going to give you 2 functions. As long as that's positive, not 0 or negative, it will give you 2 answers. All right. So the next thing we took a look at, folks, or the next lesson was solve by factoring. Okay? We're going to go over the factoring because I know people struggled with 5A tests. So I'm going to do an example here to make sure you're on the right track. And when we say to use the 0 product property, remember you have one side equaling 0. So if you've got, for example, a times a minus 5, you're either going to let a equal 0 or a equal 5 because left side has to equal right side. So how do you get the right side to equal 0? Okay, so either a has to equal 0 in this case, or a has to equal 5. Because when you sub in 5 for a there, 5 minus 5 is 0. Okay? If you're stuck with that, folks, come and see me. But we use that for all of our factoring properties, okay? For all of our factoring. So let's just quickly take time to go over each type of factoring and an example. So first of all, common factoring, you always try to common factor first, and you're looking for the greatest common denominator, or greatest common factor, GCF. So taking a look here, folks, what we have in common here is a 4t, so what's left over is t minus, I apologize, back that up, it's 2t, my fault, let me back that up. Okay, so it's going to be 2t, and it's going to be 2t minus 1 equals 0. Okay, once you've got your factors done, you let each factor equal 0. So either 2t equals 0 or 2t minus 1 equals 0. To get t by itself, divide both by 2. So in this case, t equals 0. That's your one solution. And the second one, 2t equals 1. To get t by itself, divide both sides by 2. So t equals 1/2. So there's your 2 solutions. Okay, 2 roots, 2 x-intercepts. Okay. Difference of squares, ladies and gentlemen, looks a little different. Okay, I'm just going to arrow over so I save some room. To do difference of squares, you set up 2 brackets. You take a look at putting a plus sign and a negative sign in. Take the square root of the first, which is going to be 2g. Take the square root of the last, which is going to be 3. Okay, and then you realize, hey, I've got the left side with factors and the right side equal to 0. So you got to solve each of these brackets. So 2g plus 3 equals 0, or 2g minus 3 equals 0. Okay? So we're going to let 2g equal negative 3, moving it over, and divide by 2. So g equals negative 3 over 2. That's one solution. And the second one, 2g equals 3, and divide both sides by 2, and g equals 3 over 2. So you could tell me that, or you could say g equals plus or minus 3 over 2. Okay, that includes both the roots, right, guys? Awesome. And that will be true, guys, for any difference of squares. You're going to have a positive and a negative root. All right, trinomial factoring, ladies and gentlemen. That's where you have your product and your sum. Okay, a equals 1. So product is a times c, which is 1 times 12, which is 12. Sum equals 7. My two factors are 4 and 3, or 3 times 4, whatever you want to put down. So to factor this, folks, it's going to be x plus 3 times x plus 4 equals 0. Okay, and this should be the shortcut way, folks. You can just go right to the answer. What do I sub in x here so that this bracket equals 0? X has got to equal negative 3. If I look at the second, that's one answer. Okay, if I look at the second bracket, what do I have to sub in there so that that second bracket equals 0? X equals negative 4. That's your second answer. Okay, again, there's two solutions there. All right, decomposition. I know some of you had trouble on your first unit test on this, so let's take a look. To do decomposition, you split the middle term and factor by grouping. So let's go over this. So product equals a times c. Remember that, folks? So it's going to be 6 times negative 4, which equals negative 24. Okay, and your sum equals positive 5. The biggest number is 5, or positive, then you know your biggest number has to be positive. So you're looking at negative 3 times 8. Okay? So those are our two factors. So we're going to leave 6x squared as it is. We're going to split the middle term. So I'm going to put down my positive one. I just tend to put my positive one down first. I like that. So I'm going to go plus 8x and minus 3x minus 4 equals 0. I look to see what's common in the first two, and you should have a 2 and an x. So you're left with 3x plus 4. Okay. What's common in the second two is a negative 1. So you're left with 3x plus 4. Watch your signs, it changes there. Okay. Notice we have a common binomial of 3x plus 4. And we're times it by our leftovers, which is 2x minus 1 equals 0. Okay, now we need to let each bracket equal 0. So it's going to be 3x plus 4 equals 0. Or 2x minus 1 equals 0. Solve the first one. So 3x equals negative 4. Divide both by 3. So our first root is negative 4 over 3. Okay, and 2x equals 1, divide both sides by 2, so x equals 1/2. So ladies and gentlemen, you will have at least one root with a fraction in it when you do decomposition. Okay, so that's factoring. All those methods of factoring are fair game on your upcoming unit test. The second method of solving was using square roots or completing the square. Remember, you have to complete the square when you have a bx term. Okay? Visible. So taking a look at the first example. Okay? So taking a look at the first example, we've got x squared. We can get it by itself. So you take the negative 36, bring it over. Okay? To get x by itself, you do the opposite of squaring, which is square rooting. And when you do that, don't forget to include the positive and the negative. So x equals plus or minus 6. So there's your two answers. X is positive 6 and x is negative 6. That's the two cases. All right, second example. We still have x by itself, so we can automatically do the square rooting. Okay, so we're going to take the square root of both sides. Okay, so remember, when you square root and you're squaring, those cancel. So you got x minus 5 equals plus or minus root 10. All right, then we're going to move the negative 5 over to become positive 5. Then you split it into its two cases. So x equals root 10 plus 5, or x equals negative 10 plus root 5. Okay? Plug it in your calculator, ladies and gentlemen, and you should have x equals 3.87. That's one answer. And x equals approximately 1.84 is your second answer. Okay? So, ladies and gentlemen, just remember that you wouldn't be able to factor these. Whenever you get a decimal answer, you wouldn't be able to factor. All right, now we're going to try the hardest one. And again, I want you to practice some of these because this is the completing the square one. And the reason why is because you have a bx term, okay? So what we need to do is we need to get this equation to look something like example 2, where you've got a binomial squared. So we're going to create a perfect square. And to do that, we're going to use the complete the square method. So step 1, folks, is take your constant term to the other side and make it negative, right? Okay, then we're going to do some work in the margin. We need to find what's the third term that goes in here to make it a perfect square. So to do that, you take b divided by 2. So it's negative 20 divided by 2. So that's going to equal negative 10. You also need to take that and square it. So that equals negative 10 squared, which equals 100. That is the number. The 100 is the number you add to both sides. And keep in mind that the negative 10 is what's going to be in your bracket after you've completed the square. So let's do that. So I'm going to have x squared minus 10x plus 100 equals negative 15 plus 100. Okay, so ladies and gentlemen, if you forget how to complete the square, you take the square root of the first, which is x, you take the sign and the value of what you wrote in the margin, minus 10 squared, equals, collecting like terms over here, and you're going to have 85. Okay? If you forget that, ladies and gentlemen, you can always step back and factor that. So product equals 100. Sum equals negative 10. They have to be the same. What two factors multiply to, product is negative 20, my fault. What two numbers multiply to 100 but have a sum of negative 20? That's going to be negative 10 times negative 10. So if you factored that out, folks, it'd be x minus 10 times x minus 10, which is x minus 10 squared. Okay? All right, now that we've got it like the example 2, we can now say, hey, how do we solve this? Currently it's squared, so you got to take the square root, so those are going to cancel, and you're going to take the square root. So I'm just going to write this down here, folks, because I'm a little short on space here. Okay, don't want to make it look too tight. So we're going to have x minus 10 equals plus or minus square root of 85. Okay, let's get x by itself. So you're going to bring the negative 10 over. It's going to become positive. Sorry. Okay, then bring it into its two spots, or break it into its two roots. So you got x equals root 85 plus 10. Okay, plug it in your calculator, ladies and gentlemen, and you're going to get approximately 9.75. And you do the other one, negative root 85 plus 10, and x equals approximately 0.78. All right, so there's method 2, folks, which is factoring by completing the square. All right, let's move on to the third method, folks, which is called solving using the quadratic formula. So remember, in order to do the quadratic formula, you have to have ax squared plus bx plus c equaling 0. Okay? So if you're subbing in a height or whatever, you got to move things onto one side, so you have one side equal to 0. Instead of doing an example right here in the quadratic formula, I thought we'd apply it to the application section where you're going to see it. All right, let's do some questions here on the application. Okay, and we'll use that quadratic formula, so keep it handy, and please make sure you get your calculators out. All right, the height of a rock that is thrown is given by this expression here, okay, where t is the time in seconds, and we need to evaluate it. So taking a look, what do we know first of all? Okay, part A says draw a sketch and determine the initial height of the rocket. So what we know is that we've got t on the x-axis and h on the y-axis. Okay, and do you guys remember that this is in standard form, this equation, and it tells us the y-intercept there? So I know I'm going to start at a height of 2. Okay, I'm going to throw it, ladies and gentlemen, and it's going to go high up in the air and it's going to come back down. So maybe I'm on a park bench, or I've got to be up high somewhere 2 meters to throw it. Okay? All right. So it says draw a sketch. So we've got a sketch, and it says to determine the initial height. So the initial height is either on your diagram at 2 or in the equation there. So you're going to say, therefore, initial height is 2 meters. And you could say y-intercept from equation. So y-intercept from equation equals the c value. All right? All right, so now that we've drawn a diagram, that's going to help us. And try to always visualize one. Even if I don't tell you to sketch one, please sketch one. It'll help you. All right. B, when does the rock hit the ground? So on our sketch here, folks, remember that the parabola has symmetry on the other way. So we start on the ground before we maybe stepped up onto our picnic table or wherever we threw it from. Okay? But however, we're interested in when it hits the ground. Okay? When it hits the ground, what's the height, folks? Height is 0. So we're going to let h equal 0. Okay? So that means when we rewrite our equation, we're going to have 0 equals negative 4.9 t squared plus 11t plus 2. All right. Now that we've done that, ladies and gentlemen, we can now sub it into our quadratic formula. Our variable this time is t for time. So we're going to use t equals negative 11 plus or minus the square root of 11 squared minus 4 times a times c all over 2a. That negative 4.9 you're going to see a lot because when it simplifies out, it's negative 9.8, which is acceleration due to gravity. You'll learn that in physics. Okay, so let's use our calculators out, folks, and simplify what's under the square root. And hopefully you get 160.2. Okay. And folks, I'm just going to save room, so I'm just going to erase this. Okay, break it into its two cases. So we're going to have t equals negative 11 plus root 160.2, all divided by negative 9.8. Plug it in your calculator, and you're going to get negative 0.17. That, folks, is going to be, if we go back to our graph for a second, guys, that's going to be this one here. Are we worried about it? No, because it's negative. We're not worried about negative time. So you can circle it as your answer, but then cross it out because it's negative time, right? We're only interested after the ball is thrown, right? Okay. All right, next one is going to be t equals negative 11 minus root 160.2, all divided by negative 9.8. Okay, plug that in your calculator, and you're going to get an answer of 2.41. Okay, and that is the one we're looking for, which is right there on your graph. Okay, so therefore, the rock hit the ground at 2.41 seconds. All right. Awesome. Next question. When is the rock at 3 meters? Okay. So I'm just going to quickly sketch this graph again. We noticed we started at 2, right? So we went up, come back down. And if we're asking when's the rock at 3 meters, we're not sure if it's going to actually get 3 meters, so it could be here or it could be here. We'll double check it after. Okay. All right, so if we know when's the rock at height for 3 meters, we're going to sub in h equals 3. So into our equation that was given, you're going to, where we see an h, put a 3. So it's going to be 3 equals negative 4.9 t squared plus 11t plus 2. Okay, remember, in order to use the quadratic formula, you got to have one side equal to 0. So you're going to take that 3, bring it over, and collect your constants on the right side. Okay, and that's going to be minus 1 when you collect like terms. Okay, let's plug it into our quadratic formula. So it's going to be t equals negative 11 plus or minus the square root of 11 squared minus 4 times a times c all over 2a. Okay. Use your calculator, folks. Simplify through. In the square root, you're going to get 101.4. So it's positive, greater than 0. I already know I'm going to have 2 roots. So what does that mean? I'm focusing on this line here. Okay, that one no longer applies. So I'm looking for these 2 intersection points right here. Okay, so let's solve them, folks. So we're going to say t equals negative 11 plus root 101.4 divided by negative 9.8. Plug that in your calculator, folks. And that's going to be 0.09. Take a look at your second one. T equals negative 11 minus square root of 101.4 divided by negative 9.8. T equals, plug that in your calculator, 2.15. So in fact, guys, there's going to be 2 answers, and this makes sense. So as soon as it's thrown, 0.9 seconds, it hits 3. We're at 2, so it doesn't take too long to get to 3. Then you hit a maximum height, and then you come back down, and at 2.15 seconds, it also is at 3 meters. Okay, and remember, it hits the ground at 2.41 seconds. So make sure your answers are reasonable. These are both reasonable. So then don't forget to say a therefore statement. So therefore, the rock is at 3 meters when the time is 0.09 and 2.15 seconds. Awesome. Hopefully that's a great review for you guys. Make sure you're checking with your teacher to find out when the test is. Check the website. For your homework, folks, create a study sheet if you need it, or use this. Go over questions that you struggle with. So if you're still struggling with decomposition, go over it. If you're struggling with square roots or completing the square, go over it. And I don't want you to do this, but wait until you're ready before you start your practice test. So once you're ready, fixing out the stuff you're struggling with, then go and do your practice test. Okay, no point in doing a practice test if you're still struggling on the concepts. All right, see me for extra help, folks. Study really hard, practice. I would like you to have an awesome result on your test. Have a great day.